Welcome back to BAS 121. Now we're going to go through example 9.1. So we've just started. Our last example was about colleges, and we talked about multiple regression. In other words, I'll go back to that example right here. We went through and we talked about predicting college graduation rates with multiple variables or multiple regressions. And we walked through an explanation of the output that you get from Excel. So we got a regression equation, and we kind of had a feeling in the last example whether it was a good fit or not. But a question comes up, should we include all the variables? In the last example we had 4 variables, and should we include them all? Well, one way to determine that is to look at these R values on the different variables. And remember, we want an R variable in our a p-value in most cases for each variable to be less than 0.05. That tells us that variable has some significance level, or remember, p-value is the probability of that value or more or extreme happening. So that by chance. So that means if the p-value is less than 0.05, it's very unlikely that we would come up with this just by chance. And since all of these in our last example had p-values of less than 0.05, we would consider this about as good a fit as we're going to be able to get. Even though the fit is not perfect, a reminder, because our adjusted R squared is 0.49, we want to include all these 4 variables. If we took them out, our model would deteriorate, not get better. But that's not always the case, as we're going to see in the banking example. Here we have, what we're trying to do here is predict the average bank balance someone has from banking data. Now, down here is the raw banking data, and you can see we want to predict the average bank balance based on age, education, income, value of the home, and wealth. So what we did is we went up here and we did data analysis. One word of caution: if you put both of these, since they're different rows, if you highlight both of these like this, you're going to get an error, because what Excel is going to say is my first line is my label, my next line should be numerical data, and it's not. So when you do this, you're going to want to grab that and not the top title. So here's the regression we get. We've got a very good adjusted R squared. In order to get a high R squared, we have to have a very high F statistics. So we have a pretty darn good model. The only thing that we want to look at is when we come to our coefficients and we look at our p-value for each coefficient, most of them have p-values of less than 0.05, but we have one standing out here called home value, which this high p-value is telling us that's not adding a whole lot to the predictor. That's not helping us a whole lot. Now, the good news is it's got a very small coefficient, so it's not changing our overall outcome very much, but we probably want to exclude this from our model. So step 1 in this finding the best models or the best independent variables to use is to construct a model using all the independent variables, which we just did. We constructed a model that predicted average bank balance based on age, education, income, home value, and wealth. We found we got a pretty good model, but we also found that the home value probably isn't a real good significant predictor. So step 2 is to do the same analysis but exclude the column of home value. So what we've done down here is we adjusted our data by taking out the home value, and then we did the same thing. We went up to data analysis, regression, and we filled as we did in the last example, all the information, and we got feedback based on this removing the home value. We still have a very good predictor. Normally it would improve a little bit. It stayed about the same. I think the reason for that is because this was being weighted so small. But now look what happened. All of our p-values for all of our variables are now under 0.05. Remember, this e means 10 raised to the negative fifth. So this is really 5 decimal places to the left, so a very small p-value. And now we have a model where all our independent variables have p-values of less than 5, and we have so we know we're using the right variables, and we have a very strong adjusted r-squared. So we know we have a very good model with the right variables, because we've now removed the home value variable because it had a p-value that was significantly higher than the 0.05. Now, if we didn't get all of these below 0.05, we would just repeat the process again, take out the next variable. You have to do it one at a time until you get what's called the goodness of fit, or the best fit we have. So that's how you determine which variables should be in my model and which independent variables don't need to be in my model. That's example 9.11. Any questions, let me know.